Hi, Dmitry here. Welcome to my next video about AA battery testing. In the comments below one of my previous videos you asked me to test Panasonic batteries, and here they are. What we have here today is old good famous zinc carbon, everyday power, something like a normal alkaline, pro power, advanced long-lasting energy, something like advanced alkaline, Evolta technology inside. I don't know why they are different from normal Evolta. So here we have just Evolta, here we have Evolta technology inside, and here we have just Evolta. The way design of the cells is a bit different, and as you can see here, Evolta technology inside is slightly lower placed in this marketing table than normal Evolta. And at the top we have Evolta Neo. So we have Evolta Neo here. They came in this fancy box. Let's open it. Here you have marketing materials. You can pause the video and take a closer look if you want. It's first batteries than that I ever saw with this marketing brochure inside. So let's put this a bit aside. We have this fancy box with 8 batteries inside, and here we have a print of made in Japan. On any different batteries we have information about where they made, but something is somewhere on the back with slight little letters, but here we have made in Japan. Just when you open the box you can see it. Let's take a look at the batteries itself. Again, design is a bit different than in just Evolta, and we have some strange size M, so probably this is some Japanese domestic size. I ain't sure. Okay, what do we have also is Panasonic Industrial Alkaline. Because they came in packaging like this, I have 48 of them. So we have lots of battery to test. Batteries. Here is a closer look to industrial variant, Panasonic power line. And of course we have rechargeables. We have just Panasonic rechargeable, Panasonic branded, and we have Eneloop line, Eneloop Lite, normal Eneloop, and Eneloop Pro. So let's test them all. Okay, let's go. First of all, let's test these ones, old good zinc carbons. Size R6, not LR6, so they obviously not alkaline, zinc carbon. Where do they mate? One moment. Made in EU, but I not see where exactly they made, but it's really interesting. Not China. Oh, I see. This one is made in Poland. Oh, that's interesting. So let's take a closer look and test them. By the way, it's quite interesting. Will Poland made zinc carbons better than Chinese ones? I don't know. Actually, I remember these zinc carbon Panasonics when they was black and blue with a green apple, and they was branded as a general purpose. But for now we have these zinc carbons not as general purpose, but for low power products. It's quite interesting how things are changed. So it's quite light for low power products, made in Poland, zinc chloride. Okay, let's take a look what they can offer us. Here we have a typical picture for the zinc carbons. We have internal resistance begin to grow at maybe middle or maybe at 40% of the capacity, and we have quite low capacity at 0.1 amps. At 0.2 it's about 300 milliamp hours, which is ridiculously low. At 0.5 it's about half of amp hour, so it's again quite low, and I think these batteries are good for devices that require replacing of battery one time per month or so. So some ZB sensors, some thermometers, and something like that. Something really low powerful, which is quite typical for zinc carbons actually. Okay, nice. Now when we tested the zinc carbons, let's switch to everyday power Panasonic. They looks like just normal alkaline for everyday situations. We have again made in EU sign here. Let's open the package, and as you can see it's not too easy, not so easy to open. For some reason it often happens with battery packaging. So what do we have here? Just made in EU, without specifying the country where do they made. Just everyday power, alkaline, and nothing more. Okay, let's check them. Let's check and see what do we have here in these everyday power batteries. Here we have Panasonic Everyday Power. It's a first alkalines in our today review, and main guys that internal resistance beginning to grow at the very beginning of the discharge. But take a look at the numbers of the internal resistance values of the internal resistance. It's quite low. So yes, it's beginning to grow at the very beginning, but it's much lower than it was in zinc carbons, so they will be better for powerful devices, and the capacity about 2 amp hours, which is not bad for alkaline. Not surprisingly good, but not bad, just something average. And the shape of the voltage curve surprisingly is the same, even for high load. Yeah, inclination is growing, but yeah, this is normal and expected for the high load. But the shape of the curve is quite good. No falling at the middle, so it's quite linear, and we have only fall at the very end, which is quite good. The batteries are fully used on these currents. Okay, next one is Panasonic Pro Power. Advanced long-lasting energy. Again, made in EU. Without specifying the country where do they made. Here you have some reorder codes, some internal Panasonic classification, the same LR6, and that's interesting that they all arranged that Panasonic brand is on top. Let's open this one, and situation is the same. Okay. In the contrast with the previous version, here we have a bit of red painting at the minus pole. By the way, the expiration date is January of 2034. It's quite interesting. And here we have information about where do they produced, made in Poland. It's again quite interesting. Okay, let's test them. Here we have the data for the Pro Power alkalines, and as you can see, the capacity is about 500 milliamp hours bigger than it was with the previous everyday alkaline. So Pro Powers are have more capacity and more energy for sure. The internal resistance is quite, in my opinion, it's quite higher. Maybe this is because we have some compromise between energy density and internal resistance, and if we want to squeeze more of active components, we need to sacrifice some components that not produce energy by themselves, but that help to keep internal resistance lower. So it's slightly bigger, but it's growing not so fast. And it's only beginning to grow fast at maybe last 10 or 20% of the charge. The shape curve more or less the same, but at 0.5 amps you can see that it's not so linear anymore. It has first non-linear part, then it has mostly linear part at the middle. What this can tell, maybe that Pro Power are less good with high charge currents. Surprisingly, they are Pro Power, so they should be more powerful because it's Pro Power, it's not Pro Capacity or Pro Energy, but it seems like with more power we taking from them, they produce a little lower energy than everyday power. It's quite surprising. And to finish with just ordinary alkalines, let's okay, let's test these Panasonic industrial alkalines. I think they are ordinary alkalines because there is no information about some special technologies inside them. The packaging are really modest, but for the industrials I think it's okay. Let's take a closer look. Just silver and black packaging, wrapping. Panasonic power line, made in EU. It seems like my camera is not want to focus on this black battery. Let's try again. Come on. Yeah. No. At least we had something. I hope you can see this. Made in EU. WA-LR6 size M. Again size M. That's interesting. And no more information here. But I think it is enough. Let's test them. Here we have the last normal alkaline, not Evolta. In the test, it's an industrial power line, which came in only in big packages, so it's not something that you can buy in pack of 4 normally. And actually nothing special here, quite decent capacity, slightly lower than it was on the Pro Power, slightly higher than it was on everyday power, and almost the same shapes of the voltage curve, so I think they are a bit better for the high loads than Pro Powers, and the internal resistance begin to grow only at the very rapidly grow only at the very end of the charge. Yes, it's growing almost all time while it's discharged, but the overall values are affordable, maybe quite low, maybe not quite low, but low enough. So I think it's just a normal alkaline without surprises. And now when we finished with normal alkalines, let's check the Evolta line. Let's start with simplest, I believe simplest one, Evolta technology inside. As you can see, it's a bit different internal reorder code. They made in Poland. Quite interesting that they not made in China or Thailand or something like that. They made in EU, in Poland specifically. That's quite interesting. Let's test them. Quite bluish packaging, light bluish, better to say, but no specific information like we have on Neo. What technology is here? What is it? I hope the camera will focus. Yeah. Also made in Poland. Also size M, AA, LR6, Evolta technology inside. Okay. Let's see what is Evolta technology and if they are better than normal alkalines. Let's test it. Here we have Evolta Tech inside our data, and as for me, they look quite similar to what we got before, except maybe a bit more energy, and at the 0.2 amps at the middle currents, maybe energy at the low currents are the same, but they are a bit better perform at the medium currents, 0.2 amps, and internal resistance is almost not growing on the way on the first half of discharge, and maybe at the 50% it begin to grow, and this voltage curve begin to drop. In this part of the discharge, it's almost constant. Yes, its voltage is falling, internal resistance is growing, but really slowly. So it's quite interesting. They have some different chemistry for sure, and this different chemistry makes them a bit better at the beginning of the discharge. Maybe if we will test them at the really low currents, this internal resistance will be low almost until the very end of discharge, I'm sure, but maybe because somewhere here polarization begins, so internal components is not, it can't diffuse fast enough, and they use it before they can diffuse. So I think with lower currents, this Evolta Tech inside may be even better. And let's go next. It is time to test just Evolta. Not Evolta Neo, not Evolta technology inside, but just Evolta. It's the color are more darker than Evolta technology inside, and as you can see, design is quite different. Power your day, ultimate long-lasting energy. As for me, the packaging looks like lithium batteries from other brands, but they are not lithium, they are just alkaline, made in EU. Here is the size, here is the internal codes, and let's see, they are quite premium. They tend to be quite premium. Let's take a look if the packaging will open normally or like we had before. Okay, guys, you are trying to say that these ones are quite premium, quite better than normal alkalines, so why do we have the same situation here? It's not what I expect to see. So what do we have here? Here we have a Evolta sign. They are they have more darker color. WA size M again, and made in Poland again. Okay, that's interesting. So let's check this Evolta Panasonic. Okay, here we have the Evolta, and well, what I can say is maybe they have slightly lower capacity and energy at medium and high loads, but they have lower internal resistance. It's visible, it's significantly lower, it's growing really slow, almost the very end, almost until the very end of the discharge. It's growing quite slow and linear. So, in my opinion, these Evoltas maybe, yeah, they have lower capacity, but in the devices like digital cameras, some game controllers, some digital devices that require high amount of power for short times. For example, when you take a photo, you need lots of current, lots of power, but for really short time, for 1 or 2 seconds. And in these scenarios, internal resistance is a determining factor. Internal resistance is the king here. And here we have quite low internal resistance. Maybe it's best internal resistance in the Panasonic alkalines that we see before. And I think this Voltas will be best option for the high power products, high power impulse power products. Let's see what we will have with the last one, with the Evolta Neo. And finally, we came to the Evolta Neo. The last alkalines in this review. Here we have unlock the power of silver. So they tend to be a bit different than other alkalines. High density, zero gap, better performance as you can see here. So it's quite interesting. We have some graphs here, and obviously after test we will have some my graphs, and let's compare. Let's see if these marketing materials are good or not. So as you can see, the design is quite different. You have lots of plus signs here. You have this new sign here. No expiration date at the bottom. Expiration date is on the battery itself, but not on the bottom pole. The packaging are quite different actually, and the design is quite different. Probably because they made in Japan, and yeah, you have a perforation here and you can rip one battery easily, so it's quite convenient. This packaging is actually very good, very convenient to use. Let's take a closer look. Panasonic Corporation, made in Japan. So not Poland this time. It's quite interesting, and shorter lifespan. Probably they are not so fresh, I'm not sure. And here we have Evolta Neo, complete different design. And actually, as for me, this design for wrapping is much better. I really like it. It's still alkaline, as you can see. It's not lithium or something like that, it's just alkaline, but it should be a better alkaline that we had before. So let's check. So here we have Evolta Neo. First of all, as you can see, the voltage graphs are quite linear, and the inclination of the voltage graph is not so high as it was before, so they performing quite good even at high load. And take a look at the internal resistance. Yeah, it's maybe not so pretty like it was for the Volta, because it began to grow not at the very end, but at the maybe 60%, sorry. But take a look at the numbers. The numbers are super low, so internal resistance of the Evoltas are super low, even after the half of discharge, and even at the very beginning, it's still quite low. It's still low as maybe some of the alkalines that we had before at the very beginning. So this Evolta Neos will perform perfectly in the high-power devices, as for me. It's quite interesting, quite low internal resistance for the alkalines. It's surprisingly low. So I think this Evolta Neos will be quite good for high-power devices. Yeah, it's not just different packages of the same cells. We have quite different values actually. So they for sure have something different, something special inside. But again, it's about internal resistance and power at the high loads and impulse power. If you want to use them in wireless mouse, for example, it will be average because the capacity may be lower than at Pro Power. It's just about 2200 milliamp hours. So these batteries are good for their purpose for high power devices. For the low power devices, they will be just too expensive and not so good like ones with higher capacity and higher thermal resistance. So keep in mind the purpose, the device for which you want to buy the batteries. And now, when we finished with non-rechargeables, let's switch to the rechargeables. First, let's test the Panasonic rechargeable. As you can see, almost 2 amp hours of capacity, 1000 of the cycles, and some interesting classification P6. I saw HR6, something like that, but P6, I see this first time. Here is the packaging, and made in China. It's quite interesting. After Japanese Panasonic alkalines, Chinese Panasonic rechargeables, it's a bit disappointing as for me. But let's open the packaging. Yeah, and it's opening even worse than all that we had before. The design is a bit unique from the other Panasonic batteries. Panasonic Corporation, made in China. Quite interesting. Rechargeable accu. And I don't know if you can see this, but here you have 2110. Probably it's a year 21 and month of October. Probably this is the production date. Today we have 20 May of 2024, so they was on the shelf for 2.5 years. Here you have where it was. One moment. Yeah, stay charged for 1 year. So after 1 year they should have 80% of the charge, and this cells was for 2.5 years. Let's see how much charge is remain and what is the capacity, what is the internal resistance, how do they will perform. Here is the raw data for Panasonic rechargeables. Here for first time we have off-the-shelf data, so I not recharged them before testing, just used them as is. And yeah, as always, for rechargeables, internal resistance are super low, much lower than for alkalines, and it's almost steady for all time of usage and only at the very end it begin to grow a little. The voltage curve almost flat, so if you have a device with a battery indicator based on the voltage level, this indicator will show almost 100% or maybe almost half, because it's starting not from 1.5 but for 1.3 volts. It will show the same value almost for the 60-70% of the capacity, and then it quickly will fade to zero, maybe somewhere here. So keep this in mind if you have some device with battery indicator and rechargeables. Let's take a look what we will have after recharging, and the value is almost the same, but capacity is growth about 200 milliamp hours. Let's go back, and yeah, here we have almost 1,500, maybe 1,000 and yeah, 1,500. Here we have something 1,000 and about something 1,600. So these rechargeables have quite good charge retention, quite low self-discharge, which is a good result. And it is time to switch to an loop line. As always, let's start with the weakest. As for me, simplest batteries, it's an loop Lite. Rechargeable battery capacity is lower than 1 amp hour. And where do is made? Where is it made? I don't see. Quite interesting. Here we have Belgium, but it's not where they produced. So, oh, made in Japan. Wow, that's quite good. It's quite interesting. Let's open the package. Package is quite interesting also, and I tried to find these packages with 4 loops inside, but loop lights inside, and I not managed. I failed to find this. I only found ones with 2 batteries, but as you can see here we have places for 4 batteries, but for some reason I can only find packages with 2 batteries. But this is fine too. Made in Japan. Design is really simple. Just an loop light, the capacity and nominal voltage. HR6, and by the way, oh yeah, we have nickel metal hydride. And that's it. So okay, let's test them. Okay, and a loop light. Actually, I'm not getting the idea of making the cells with such low capacity, 600 milliamp hours we have here, but maybe they have the niche, maybe they have lifespan about thousands and thousands of recharges. I can't test this obviously, because it will take years to test, and one power interruption will ruin anything. But for some reason they are available. Somebody making them, somebody buying them. Let's take a look at the values. Except surprisingly low capacity, but yeah, they are light, so it's kind of expected. Except this quite low capacity, anything is typical for nickel metal hydrides, and they handling high loads very well, but this is about 1C for them. But anyway, they handling this high load very well with very low internal resistance. Let's take a look what we will have after recharging of them, and almost the same capacity, maybe a bit higher, which is quite good. This means that they have low self-discharge, and if you will charge them and put them on the shelf, they will good to go even after some time, 3-6 months living on the shelf. But the capacity of these lights are quite low, so keep this in mind if you will decide to buy them. Now let's test normal loops, not light and not pro, just loops. New packaging, less paper, okay, 2 amp hours of capacity, rechargeables, recharge up to 2100 times. It's quite interesting. It's not normal for rechargeables, and after 10 years of storage they offer 70% of charge remains made in Japan, so characteristics are quite good. Let's test them. Oh yeah, let's take a closer look at the battery itself. Made in Japan. To amp hours, ready to use rechargeable battery. So design is also quite simple. Let's test the characteristics. After all, we want a good rechargeable battery, but not the good design one. Let's test them. Here we have normal and loops. Internal resistance of them is so low that my device considers it's negative. Obviously this is a mistake, but just my device cannot measure so low internal resistances, and this is quite good. This means that these batteries will work quite well in things that require lots of power, like flash guns for photo cameras, something like that. But again, we have, for some reason, quite low capacity, just about 1300 milliamp hours. It's surprisingly low, but okay. Let's see what we will have after recharging. And after recharging, we have almost 1600 milliamp hours. Keep in mind that my device is homemade, so it can show not exact values. It can show capacity lower than it in fact is. What we want to check here is how same batteries, how the same brand, how batteries from the same brand work, compare one with another, which one is better, which one is cheaper, which one is better for high loads, for low loads, and so on. And another thing what we're testing here is self-discharge, because here we have off-the-shelf situation, so they lose some charge after storage, and here we have freshly charged after 1 day of setting in. And for any loops, I see that this difference is a bit bigger, maybe because they have higher self-discharge, or maybe because they spend several years, maybe about a year on the shelf, because I don't know how long they was in storage, and more important, what was the conditions, because if they was stored in some very hot place, self-discharge will be bigger. Well, except that, the voltage curves are quite good, quite flat, especially at the very beginning of the discharge, and the voltage is quite high. So your devices that are oriented for AA alkalines, I think the devices will be happy with these loops. And the very last batteries for today. It's an Eneloop Pro, ready to use, 2.5 amp hours of capacity, They come pre-charged, high capacity, ready to use, and they are high capacity, but we have recharge up to 500 times only. It's a significant difference from the previous ones, so it's four times more. And where do they made? Made in Japan. Quite nice. After 1 year of storage, capacity remains 85%. So no information about what will happen after 10 years of storage. So probably they have not that good long-term characteristics. Self-discharge seems to be higher, and cycles seems to be much lower than with normal in loops, but the capacity is better. What about internal resistance? Let's open and take a look. Oh, we have a nice case. When I say that we want a battery, not a design, I mean that if we have good design, it's okay. If we have simpler design but good battery, it's essential, it's quite good. So I prefer the characteristics over the design. But if there will be good design, well, why not? So 2.5 amp hours, made in Japan. Loop Pro, high capacity, ready to use rechargeable battery, and nothing more. Black top, and I don't see information about. Oh yeah, production date is 11 month of 23 of year of 23. Okay, let's take a look. What do they have? What do they good for? Let's check them. And the last thing here is a Loop Pro. The internal resistance again sometimes so low that my device considers it's negative, but while we taking some power, it's growing. For some reason, the capacity is quite low off the shelf, and for some reason, this voltage fall begin at maybe 85%, which is quite too fast for nickel metal hydride. But maybe this is a price for so low internal resistance. Let's take a look what we will have after the recharging. And we have much better capacity and more normal form of the curve. Let's go back and see we had capacity almost about 1100 milliamp hours, and after the recharge it's about 2000 milliamp hours. So probably Loop Pro have bigger self-discharge. I don't know why. And also one important, maybe not important, no, not important, just one interesting thing. I don't know why it's happening. Just let's take a look at the values of the freshly made cell of the shelf, and let's take a look at the values after I recharge them. For some reason, internal resistance is growing. The shape is the same. It's keeping almost strained until the very end of the discharge, so it's flat, but the average value is quite higher than it was before. I don't know why this happens. If you have some ideas, please drop it in the comments. Okay, here we have the finishing diagram. Here we have all our Panasonics, and we have the capacity of them. 4 different currents for 0.1, 0.2, and 0.5 amps. Here we have NL loops, rechargeables, zinc carbons, and alkalines. So, what interesting do we have? What is interesting here? First of all, if you want a battery that will last long as possible in the low power devices, like wall clocks, something like that, you should take Pro Power or Power Line, because the capacities are best here. And if you have something for medium power devices, you should take again maybe Pro Power, maybe Power Line, and maybe Evolta Neo. But again, keep in mind that we talking only about the capacity for now, so it's important for the devices that require constant current. And an Pro is again is something that can compete with alkalines here. And for max current application, you should take an Pro, or if you want to take alkalines, you should take Evolta Neo, because Neo have almost the same energy capacity as the high current like Eneloop, and bigger than all other flavors. But most of the devices require energy, not capacity. So most of the devices not have constant currents, they have maybe more or less constant energy consumption. And here we have slightly different picture. Here we have for the low power, the leader is Pro Power and maybe Power Line. Again, for the medium power, it's a bit different. For the medium power, Pro Power still keeping the first place, and Power Line and Neo from alkalines are sharing the second place. But if you consider rechargeables, Eneloop Pro is quite good here for the medium currents. And for the high currents, you should take rechargeables, Eneloop or Eneloop Pro. And if you want to have alkaline rechargeables, so Evolta Neo is maybe the best option here. You may see that, okay, we have something here, it's bigger than Neo, but this is Panasonic rechargeable. Actually, quite average, and the results is a bit lower than Eneloop has, but it's cheaper. And the last one, internal resistance, which is quite important for really high power applications. As usually, here we have the leaders from the rechargeables. And all alkalines, and especially zinc carbons, have much bigger internal resistance. Here we have the diagrams that show in the chemistry of the battery. Alkalines are more or less the same. Zinc carbon is outsider here, and rechargeables again more or less the same. By the way, if you forgot, these colors are beginning, first 25%, second 25%, and end of the discharge. So this is fresh battery, slightly used, normally more or less used, and exhausted. And for the nickel metal hydride rechargeables, it's almost the same. So this means that it will work in your camera until the very end of the discharge. And alkaline probably will die about when it will discharge at about 50%. So that's it about the Panasonic batteries. Please write in the comments what do you think about this all? What battery is better for you and what devices do you use? And have a nice day. Thank you for watching. Bye.